Hello, everybody. We are in week 12 of the course, and this is chapter 13. So we're thinking about essentially antibodies and the immune system and vaccines. So there's going to be a bit of this lecture that's going to remind you of a Principles of A&P class, if you've had that already. And so I won't shy away from some of the topics that tie into your Principles of A&P class, but I'm not going to hold you responsible for that level of the material. So let's get started. So our immune system has three lines of defense, right? The first line of defense is passive, skin and mucous membranes. Second line of defense are some generic white blood cells that are going to go out there and kind of help us out, maybe if you've cut yourself or something like that. The macrophages and natural killer cells are two examples. And then we have the third line of defense. So this is truly when your immune system is responding. It's launching for real. And so there's a cascade of events that's going to occur, and the ultimate result is making antibodies. So let's think about that antibody production by the immune system, but now let's go back and talk about antigens. So antigens essentially are usually polysaccharides or proteins that are on molecules that help our cells differentiate between what is self cells or what are self cells and what are foreign cells. So think about them as just tags on cells that have their social security number on it or something. So if you get something that's not essentially your own kind of code, then your body is going to go, okay, what's this? And so that's how we initially start the response of the third line of defense. So some of you might remember that there are macrophages, and they're called antigen presenting cells. And again, that essentially is going to launch this third line of defense. But it all starts with recognizing what is self and what is foreign. So these molecules that your immune system is using are what we call antigens. Usually we're not, how do I want to put this? Usually our own antigens aren't going to elicit a response. So this way your body can differentiate between what is self and what is not. So it says any exposed or released protein or polysaccharide is potentially an antigen, even those on our own cells, but usually we do not respond to that at all. Okay, so this very, very busy figure is from your textbook, and I cut off the top part, which is essentially like first and second lines, or really second line of defense. But this launching of the third line of defense and the production of antigen-dependent responses is what we want to talk about. So for those of you that's already had this in Principles of A&P, you're going to remember that these essentially antigens are going to be processed by a special type of cell called a macrophage. And actually that macrophage is actually active in the second line of defense, and then it kind of is going to then take it upon itself to launch the third line of defense. Now, you don't have to look at this right-hand side of the graph or the figure, but for those of you that remember this from PAP, this is the T cell portion of this response. So T cells are most definitely helping, but we want to focus on the left-hand side of the figure, where essentially we are making B cells. So here we see the B cells actually come in from the helper T, but anyway, here's a B cell. It's going to be activated, and it is going to essentially make antibodies specific to the very antigen that you've been exposed to. So here it is, cranking out antibodies, and they go into the bloodstream to wherever the source of infection is. Now you notice that this activated B cell is also going to do a very important process, which is recording the memory of your exposure. So this allows you to have longer term immunity to the very thing that you are exposed to, or to that antigen that you were exposed to. So essentially we know that the immune system is going to use a variety of cells, but in the end, this third line of defense is helping our immune system by making antibodies that will directly attack the antigen. Excuse me. And it will also record the memory of that in memory cells, so you have those for later. Okay, so now we're going to just define a little bit about what's so special about antibodies. So antibodies give us specific immunity, and we also call this adaptive immunity because your immune system is adapting to the very antigens you've been exposed to. If you're exposed to, let's say you start working in a daycare center, or maybe you recently had sent your child to school or to daycare, and then suddenly you're getting sick all the time. So for your child and for you, every time that you're exposed to a new antigen and the immune system needs to launch, it doesn't always need to launch, but if it makes it past the first and second lines of defense, then we're going to launch the immune system proper. And in that case, your immune system is adapting or going to produce very specific antibodies to the very thing you've been exposed to. So if something's going around the daycare center, it might be, norovirus, it might be other forms of virus induced gastroenteritis, maybe it's, the common cold. And so you might have been exposed to 3 or 4 or 5 different things over the course of your few months at your new job, or your child going to daycare and coming home and getting you sick. So what we know is that these antibodies are specific to the very antigen you've been exposed to. So it's not going to be specific to something else. So specificity is super important. Antibodies produced against, for example, the chickenpox virus is not going to work against the measles virus, right? It's just, that's not a thing. And that's the beauty of antibodies, is they're highly specific. And then we also know that part of this adaptive immunity is essentially making a special kind of B cell, and these are B lymphocytes, and essentially they are going to record the memory that you were exposed to that, so that the next time you're exposed to that exact same antigen, then it can launch its defense. So usually you're not going to get the same variant of a cold virus over and over and over again, but we do know that colds and flu viruses and even the COVID virus mutate. So whatever you were exposed to before may not be the one that you're exposed to again. So I think there was 4 or 5 or maybe 6 different variants of the COVID-19 virus. And so a reason why we're getting new vaccines is so that we would have immunity to the new strain going around. Okay, now your book goes into at least 4 or 5 different ways that antibodies are going to function to fight an infection. And what I really want you to know, A, they're highly specific. B, they're literally going to go and attach to the very thing that you've been exposed to. So they're going to stick to the antigens and essentially are marking them for destruction. So there's a whole nother thing that needs to happen. But essentially, antibodies attack the cells with the antigen on it and are going to mark them for destruction. So that way you're going to eliminate those foreign cells in your body. All right, so B cell activation, you can pause this if you like. So this is a slightly different version of the figure we saw before. But the most important thing is we see that a B cell has been activated. Again, it's by a helper T cell, which is up here. And then we see we are going to make plasma cells. And plasma cells are those cells that are going to make the antibodies for now, okay? So yeah, it's going to take a little bit of time. So you were exposed to the flu or exposed to, maybe norovirus or something. And so you're going to be sick for a couple of days. You may not even notice that you're just getting worse or you're just not feeling great. But the thing is that part of the reason why you're not feeling great is because your immune system is launching. And it takes a bit of time to make those antibodies for that specific variant of norovirus. And you see on the right-hand side of this figure that this activated B cell makes plasma cells, and the plasma cells are cranking out antibodies. So that's going to take some time. Let's say you were exposed to that same norovirus again, fairly soon after you had it the first time. Well, in all likelihood, you're already going to have antibodies. You're already going to have a recording of that exposure. And so you're going to have memory B cells, that are going to be ready to crank out antibodies at that second exposure. So in all likelihood, you won't even know that you were exposed again because you have the antibodies attacking those foreign antigens on the norovirus and marking them for destruction. And so you're going about your day or your week or whatever. Okay, so we're going to dive into different aspects of how we've essentially tweaked um, our immune systems to work a little better for us, or we have used immune systems of other organisms to benefit us. So we are going to differentiate between natural immunity and artificial immunity. So when I think about natural immunity, it means I went through some experience myself. I was exposed to that virus, exposed to that bacterium. And so the immunity that I have comes from that third line of defense launching and all the things that happen, helper T cells, activated B cells, plasma cells, memory cells, all the things. And so I have built up this response. Okay. So natural immunity is when you're building it up from biological experiences as an individual. So another way that I might get natural immunity is in utero. When I was growing in my mother's uterus, she did not breastfeed me, but certainly we can get that through breastfeeding. So while I didn't actively do anything to get that, it was through normal biological experiences. So being in utero, we have the mother's antibodies crossing the placenta into our bloodstream. And so it's natural because it's part of everyday life experiences, but I didn't actually do it myself. So we'll come back to that differentiation. So artificial immunity is when essentially you're getting antibodies from someone else or another organism, like another animal. So we get protection from infection obtained through medical procedures. And this includes vaccines because we're essentially introducing something into our body to make it launch. Or let's say I've been exposed to rabies and then I have to get serial injections of antibodies to rabies. So I'm getting that because that was made in, I can't remember if it was sheep or whatever it is, but something. And so that's been purified and then given to me. So that's artificial immunity, essentially when we're giving antibodies to other people, or we are giving ourselves something that's activating our immune system by medical procedures. Okay. All right. So we have a couple more minutes on this video. So let's take a look. On the left-hand side, we have these natural immunity examples. Again, acquired through normal life experiences. So the one on the left side, active, you got sick, bam, bam, bam. You made plasma cells, which made antibodies, and now you have antibodies. So natural and active. You got sick through normal life experiences, and you launched your immune system, and now you have the antibodies for that. Passive natural immunity is when we're picking that up either in the uterus or through breastfeeding. So it is natural in the sense that it's through normal life experiences. Okay. On the right-hand side, we have artificial immunity. So active, artificial, your immune system had to launch, but it was due to essentially the introduction or the injection of a vaccine. Okay. So we're not going to consider that natural because we had to do something to create that launching of the immune system. So it's artificial because it's through medical means, but active because your immune system had to go through all these stages and then crank out antibodies, both through the plasma and memory cells. So you have this recorded cells specialized to make antibodies if you're exposed to that particular disease, whether that's measles or mumps or COVID-19 or flu, HPV, whatever. So artificial passive is when we are literally giving antibodies to a person. So that's maybe someone who's immunocompromised, maybe someone who can't actually get vaccines, but they've gotten sick, so we want to help them. We will come back to this when we talk about convalescent therapy. Well, I guess I should just mention it. During the COVID-19 pandemic, if someone got sick and launched their immune system, like you would expect, to COVID-19, then they made antibodies against that particular virus and variant. So people were giving blood or essentially convalescent donations of blood so that they could give those antibodies in that blood to people who were severely sick. Okay, so that's an example of passive artificial immunity. Okay, we will continue on in a bit. I'll see you in that video.